Okay, so we talk now about cryptographic support for data sharing, and as I said in the last two lectures, I'm talking about these topics mainly to give you some ideas of alternative ways of protecting your data, and in some ways, some, if one wants to term it this way, futuristic ways of protecting your data. So we look first of all at transforming passwords into keys, and then we talk about some encryption tools and a few case studies of things you can do, for example, to protect data on your computing device, data that can be accessed, for example, to load onto your social media platform. So you've had, for example, cases in which your social media platform was requesting access, for example, to your location or to your photographs or to data that is on your system. So you want to try to protect this data so that it is not accessible either with your consent or without your consent because you, by some mistake, clicked on some button that you should not have clicked. Okay. Try to remember that you should never use a password that is rated less than strong. It is not a good idea because it is useless or counterintuitive to the idea or to the notion of even having a password in the first place. Okay. Microsoft provides a nice free password checker accessible on this link. So basically what you do is to choose your password and then run a little check to determine if your password is secure. And it should be able to tell you, for example, whether it's weak. If it's weak, what you want to do is to choose a different password. If it says it's strong, then that's a good start. But if you could make it stronger, that is even better. So in cryptography, as I said in the previous lecture, a key is like a piece of information that determines whether or not you're allowed to decode some other piece of information. And the concept is not new. So for example, in the Roman times, Julius Caesar invented the Caesar cipher, which was basically the method that he used to transmit messages between his different military units. The Egyptian cipher existed also for the same reason. So it always starts with the military wanting to transmit messages in a secure way. And the reason that they want to do this is, of course, because these messages are important. They need to be transmitted to the people that they should be getting to. And if they are intercepted, they should not be decodable because people can die because these messages have been discovered. Okay. And so in order to create ciphers, the methods that used to be used in that period were not very sophisticated by comparison to the methods that we have today. But I thought that we should look at those methods in order to get some idea or feel of what it is like to create a cipher, or create a cipher. So basically, if we imagine that we have plain text, right? And that in plain text we have the characters in uppercase of the English or the English alphabet, for example, okay? And then in ciphertext, what we want to do is to create an alphabet that is similar to this alphabet, but by transposing the different symbols in ways that allow us to understand that the symbol that we have represents something else with respect to what we want to decode it as for the plain text. Okay, so for example, if we decided that we want to shift this alphabet 4 places, and imagine that you have only 26 slots, what is going to happen is that you're going to move all of these 4 places forward, and so this chunk of the alphabet will fall off. So what we want to do then is to move it to the beginning, which is why we have this here. Okay, so in the ciphertext, what is going to happen is to say, okay, when we see for example, W, what it means is A. When we see X, what it means is B. When we see Y, what it means is C, and so on. And so basically, you find that what is written down is completely different from what it actually is supposed to mean. So as I was saying before, basically what we want to do then is to translate our plain text into ciphertext. Okay, so for example, if we have in plain text, the cat jumped over the moon, and we were transmitting this, for example, to some unit or to somebody in encoded form, then basically what we would do is to translate T, for example, for P, H, for example, for D, E, for example, for A, C, for example, for Y, and so on. And this is basically what we would have in the end as the coded message that we would be sending to the person who is meant to be receiving this message. When they receive this message, because they know that the message was sent to them by, for example, myself or by some party whom they know and with whom they had agreed to before about this encoding scheme, what they will do is to translate this message back into what they are expecting or what they think should be the readable form of the message. So for example, in this case, then P would be recoded, looking at the coded form of the message, into T. D, for example, which we find here, would be coded into H. A, for example, which is here, would be coded into E. Okay, and basically this gives us there, which is what we are expecting. And if you went on to decode the rest of the message following the same scheme, for example, you would find that you end up with cat for Y, W, P, and so on. And so at the end, you should get the message which says the cat jumped over the moon, which is the real message that you're wanting to be reading. And so the hope is that if this message falls into the hands of the person who should not, some person who should not be receiving the message, then what happens is that the message doesn't make any sense to them. So they are likely to throw it away or to try decrypting the message or decoding the message, which hopefully will take them quite a lot of time. So some encryption tools, okay, so we've talked about, for example, public key encryption, and what I just talked about was to give you some feel of how encryption works and how the fact that in order to decrypt the message, you need to know exactly what sequence was used to form the encrypted or to form the coded message in the first place. You can have encryption tools which exist on the internet, for example, like TrueCrypt, BitLocker, for example, and pretty much they work the same way, except that, for example, they use public key encryption, for example, in order to transform your password using some sort of code that works pretty much as I explained to you in the previous slide of transforming the characters in your password into some cipher characters that are then used to encrypt your data using some formula that transforms the data. And when you need to decode the data, what happens is that the reverse process happens. So the message needs to be decoded based on the based on you supplying the correct, for example, password that is translated into some key that is then used to decrypt the data. And so if you provide the wrong password, you're not going to be able to access the data. Okay. Encryption tools will allow you to protect content that you post, for example, will not allow you, to protect content that you post on social media platforms because, as I said before, the data is not owned by you and because you don't have direct control of the data. Okay. But there are some encrypted social networks that are emerging in which you're allowed to post encrypted messages. So there are encryption protocols for allowing you to post messages. Examples include, for example, SIME, okay, which you could get just by Googling and to decide to download. The downside is that because not many people are using this, the whole benefit of using a social media platform is lost. Okay. Okay, so basically if you decide to encrypt data, what you will likely be encrypting is the files that you have on your hard drive, for example. You can decide, for example, to encrypt cloud storage. So for example, if you decide to store files on Dropbox, you can use, for example, some second encryption layer to protect the data that you are posting on the cloud storage platform. So I should say at this point that most cloud storage platforms will provide some basic encryption to protect your data, just because they have to ensure that who is supposed to be accessing the data is who actually gets access to the data. You can also encrypt, for example, email and internet traffic. So you have, for example, sometimes when you're sending a message and you need to send a secure message, you can encrypt the message, and there are protocols for decrypting these messages on the sender and the receiver ends. Okay. And then you can also decide to encrypt, for example, external drives and external USB devices. And the reason that you want to do this, as I said before, is because you want to protect the data that you have on these devices from automatic requests from social media platforms, for example, and other applications that are wanting to access data on your system. So this brings me to the last point on this, which is basically to reiterate and to re-emphasize what you need to look out for when you're agreeing to use, for example, a social media platform, in terms of what levels of privacy that the social media platform is going to be providing you with. And these statements apply also to other applications, other internet applications that you might be using. So for example, you want to find out exactly who owns the data that you post. In most cases, it's usually that the service provider owns the data, okay? You want to find out what happens to the data when your account is closed. So on a lot of social media platforms, you never really have deleted or closed your account. It always exists somewhere in some dormant form, and you could, if you wanted to, reactivate it if you decided to change your mind. If there are changes in policy, you need to find out how they make them known to you. For example, you don't want the policy to change from that you are allowed to own your data to the fact that the social media platform, for example, owns the data and not know about this, because this obviously has an impact on the way you interact with the social media platform. You need to think about what content you're posting on your profile page and what happens if that is completely erased, and what exactly that means in terms of the deletion of your account. Okay. Other things to look at in terms of breaches: where do you complain? So for example, if you get unsolicited messages, where do you complain? How do you prevent such users from being able to interact with you in the meantime? And thinking also about things like how long personal information is stored, because this creates a digital footprint, and you want to think carefully about what impact this is going to have on your person in the future. Okay, so today I basically talked about cryptographic support for data sharing and some simple mechanism for how messages are translated or encoded to form coded messages, and how we then work to decrypt these messages or to decode these messages. In the next lecture, I would like to talk to you a little bit more about encrypting data, and moving on progressively towards talking about things like, for example, what happens if you don't use social media platforms, for example, and how in any case you're going to be creating a digital footprint, whether you like it or not, just because everything works today with computers.